Hey guys, welcome back to my YouTube channel. My name is Tamara Gamboa and today we're gonna talk about seismic waves. So now, let's go through what seismology is in general and what are seismic waves. Seismology is the study of earthquakes and seismic waves that moves through and around the earth. Seismic waves are the waves of energy caused by the sudden breaking of rocks within the earth or an explosion. There are 4 types of earthquakes. There is the tectonic, volcanic, collapse, and explosion earthquakes. A tectonic earthquake is one that occurs when the Earth's crust breaks due to geological forces on rocks and adjoining plates that cause physical and chemical changes. A volcanic earthquake is any earthquake that is caused from tectonic forces which occur in conjunction with volcanic activity. An explosion earthquake is an earthquake that is the result of the detonation of a nuclear and/or chemical device. And finally, a collapse earthquake are small earthquakes underground caverns and mines caused by seismic waves produced from the explosion of rocks on the surface. Now, let's focus on the seismic waves. There are 2 main types of seismic waves, the body and the surface waves. The body waves arrive before the surface waves emitted by an earthquake. These waves are of a higher frequency than the surface waves. There can be different types of body waves, such as P waves and S waves. P waves are the fastest kind of seismic waves and the first to arrive at a seismic station. It can move through solid rocks and fluids. It pushes and pulls the rock it moves through, just like sound waves push and pull the air. The S waves are the second waves you feel in an earthquake. An S wave is lower than a P wave and can only move through solid rock, not through any liquid medium. The surface waves are of a lower frequency than the body waves and are easily distinguished on a seismogram. Though they arrive after the body waves, surface waves are almost entirely responsible for all the damage and destruction associated with earthquakes. A seismograph is an instrument that is used to record and detect seismic waves. They cause vibrations that carry energy from the source of an earthquake to all directions. They travel through the interior of the earth and can be measured with sensitive detectors called seismographs. Scientists have them all around the world to track the movement of the earth's crust. As you can see, this is a seismograph with the arrival of the P and the S waves. This graph proves that the P waves comes before the S waves, and after that, the surface waves comes and are easily noticed. Now I'm going to explain how math is used in seismology, specifically how logarithms are used in seismology. With logarithms, you can find the Richter scale, the measuring magnitude of earthquakes, and the actual measurements of the earthquakes and other practical ones. So how do we use logarithms? You use it with the formula mb equals logarithm of 10 a over 7 plus q. The a equals velocity, which is 40, the t equals the period, which is 5, and the q means the depth and the distance, which is 0.01 times 24.7 plus 5.9. After plugging the numbers, that will be the equation we will be solving, and the answer will be about 7.1. In this lab demonstration, as you move the slinky, you can see how the P wave behaves. It has a direct impact. On the other hand, as you move the slinky to represent how the S waves behave, you can see how it moves side to side. In this second lab demonstration, I'm gonna show you and explain how the 3 types of plate tectonic boundaries move. So first, you can grab 2 pieces of boxes or whatever material you want and then show how the strike slip moves, that is when the faults are moving past each other, the divergent when they are moving apart, and a convergent when they are moving together. This is a short review of what we learned today. So that's it for today, guys. Thank you very much for watching my YouTube channel, and I'll see you next time. Bye!